Okay, so we started with just general quadratic equations and then word problems that had an equation given, and then we started to talk about regressions where you make your own equation. I want you to think of, especially when it comes to the story type, where you have 2 points given, you'll find a third one. Quite often you'll be using this one. Recall, axis of symmetry is x1 plus x2 divided by 2. At the very top, if you wouldn't mind adding this. I won't necessarily always use this formula, but this is what it's based on, okay? That is the mechanism behind what I'm going to be doing today. It is actually abiding by this fact, right? And how does this go again? If you've got two x values that are right across from each other, we add them up and then we divide it by 2 to get the middle, to get basically where is the middle, and that'll be the vertex, right? So you'll be given 2 points and you'll have to find a third point using symmetry. So one thing, the best way to solve this type is to sketch it first, and then remember that the third point is going to be across your starting point. And here are some scenarios. Right? Let's say the vertex is given. Okay, so the vertex is given here, is provided. And I made these very, very basic. So imagine these scenarios are, the first one is we're starting on the ground. So here's a very simple problem. A ball is kicked, reaches a maximum height of 17 feet after 1.25 seconds. Would you agree that this is referring to the vertex? If it says reaches a maximum height, right? You can tell this is the vertex. This is like the top, okay? This is your vertex right there. So how about, imagine you're going to sketch this, and by sketch, guys, listen carefully, I mean a sketch. I'm not going to mark you on scaling. Like if I don't ask you to graph it, a sketch is just for you to have reference, okay? That's all I'm asking for. So we're going to label this point right here. Knowing that time always goes on the x-axis and the y goes on the y-axis. Don't forget that. So if it's 1.25 seconds that it takes to reach 17 feet, you have to put it in this order. Okay. Please don't mix that up. If you have it the other way, you're saying it takes 17 seconds to get to 1.25 feet if you have this mixed up. So don't get that wrong. So the vertex is given. Perfect. Do we know this point right here? It's overlooked, but it's very easy and it's very powerful. When you're on the ground, you're at height 0 and you're at time 0, right, at the very beginning. So this would be 0, 0 for me. The question never explicitly states it, but it's implied, meaning it's hinted, right, that we're starting on the ground and it's at time 0. So we've got 1, 2 points. We need a third one. Guess what? The third one is, one way to find it is go across your starting point, right? So we're going to go across and just say, hey, there's a point right across from where we started. And we know that the y value will be 0 as well, because we were at 0 at the beginning, so we're back to 0. Now, what is my x value here? This is where the axis of symmetry comes in. I'm going to grab a ruler, if you have one, or something to make a straight line. I'm going to count on the axis of symmetry to help me out here. So in terms of just look at the x values. You start at 0. How many units do you travel to get to the center from the left? 1.25, correct? So how many units is it going to take you from the center back across to the other side. 1.25. So in a sense, we took the 1.25, we're going to multiply that by 2. We're going to multiply that by 2 to get our new x value. This is going to take us 2.5 or 2.50 seconds to get to that point. This is the third point that we need, okay? This one right there. It's very important. We need that third point for us to be able to come up with an equation. So that after you've done your sketch and you've determined, okay, I've got the start, I've got the highest point, which is the vertex, I can use that, I can use the symmetry of the parabola to find another point. So we go time and height, we go 0, 0, 1.25, 17, right? And then last but not least, 2.5 or 2.50 back to 0. You type this into L1 and L2, you do your thing, you press a bunch of buttons, boom, you've got your equation. What about this scenario here? You're off the ground, okay? Sometimes you'll start off the ground. You won't be at ground level. Let's read it. An object is thrown from a height of 8 meters. That's important. Reaches a maximum height of 13 meters at a distance of 3.5 meters. If it says maximum, folks, you should say, hey, maximum or minimum, right? If it talks about anything using those words attached to it, you know that it's referring to the vertex. So just so you know, sometimes you'll have distance, not just time, along the x-axis. So distance means horizontal distance, and height is obviously vertical, right? So let's label this. Distance comes first, and the height comes second. That's important to not mix them up. Where do we start here? At a height of 8 meters, right? So this would be 0, 8. And this is important now. You want to go from your initial, you want to go right across. You know that you are able to find this point right there. And along comes the axis of symmetry again. Okay? Okay, so I picked easy numbers. So it takes 3.5 seconds from here to, or not seconds, sorry, a distance of 3.5 meters to get to the middle. Guess what? It's going to take another 3.5 to get to the other side. So we know that the height 8 stays the same, right? We're staying along the same height, so this is 8. This is the number that we need to figure out. It's going to be 3.5 and another 3.5, which is 7. Or you can just think of that as, right, I need to multiply that by 2 to give me that 7. Okay? So that's your third point. Now you can do it. So we go distance and height, 0, 8, 3.5, 13, and 7, 8. You've got your 3 points, L1 and L2, and so forth. Yes? And that's just it. Now that you have these 3 points, you can enter it into your calculator, come up with an equation, and then once you have the equation, you can figure out any points that's missing. You just need to give the calculator 3, and then it's like, oh, I got it, I know how it's going to go now. I just need 3 and I can model anything for you. Yes? So the vertex is the highest point. It splits the entire parabola evenly, but you got to be careful that when you start off the ground that you focus on going across right here, right? So this axis of symmetry will split this little stretch in half, right? Does that make sense? This little part here is split in half by it. As you go further away, this is obviously not half and half, right? So it's only here when you measure, when you start at a point and you go right across, that's where you want to focus on. Yes, absolutely. So this question would definitely be ripe for me asking how long will it, like how far away will this object land from the original point? It will ask for that x-intercept. Yeah. Does that make sense? So once you have an equation, but you need to focus on these 3 first, then come up with your equation. One thing I don't want you to think is it's always going to be like this, always, every single time. There have been questions where all 3 points are given. Like the problem actually mentions all 3 points. In that case, way easier. Just come up with a table, put them into L1 and L2, and away you go. I'm just focusing right now on the ones where you don't have all 3 points. So you need to come up with a third. Okay? Let's do this one here. This is where the vertex, no vertex provided, okay? So the vertex is kind of, it's missing. But it can't be completely missing. They need to give you enough information, but you'll see what I mean. If you're on the ground, let's read this question here. An object is thrown upwards, reaches a maximum height. Oh, there you go. That's definitely referring to the vertex. A maximum height of 40 feet. Lands and remains airborne for 8 seconds. What is that? We're throwing it upwards, so we're starting at 0, 0. That's the implication. They're not telling us we're like up somewhere. So this is for sure. It says that the maximum height is 40. So we know that at the vertex, this height will be 40. We just don't know how long it takes to get there yet. So that's my unknown. Go to this end. Do we know this? It takes 8 seconds. It remains airborne for 8 seconds, meaning it stays in the air for 8 seconds until it hits the ground. So the 80, I'm going to label it right here. 80 is given to us as well. So guess what? Axis of symmetry. It's 8 from here all the way to here. It's 8, right? So what does that mean about these 2 stretches? 4 and 4. So now that we've determined that, we know that this is going to be 4 here, because it takes 4 seconds to get to the highest point, to get to the center. So you either do it this way, or you just realize I have to split this in half to get to that. And that gives me 4. Okay. So that's what you would do there. And so time and height, 0, 0, 440, 80. And L1, L2. I could ask you, what's the height of this object after 6 seconds? It's going to be somewhere here, right? How long does this object stay at or above a certain height? I could ask you the same things that I asked you before, okay? And 7, let's do this one here. A skier goes down a 30-foot ramp. the lowest height it reaches, right, is 12 feet. And reaches the initial height at a distance of 50 feet. This one is a little harder, right? But the lowest height is this. That is my vertex for sure. Part of it. So this is probably one of the more challenging ones. But we're told that we're starting, and this kind of gives it away, but we're starting this way so that you get used to the concept. So we're starting at a height of 30. We go down that ramp. We're gonna reach a maximum height of, a minimum height of 12. We don't know what the distance is yet. It's unknown to us. And I apologize, I should have made it a little bit more, like I should have given it a bit more of a dip. But we're gonna focus on this point right there. What do we know about that point? Read carefully. It reaches the initial height. What is our initial height? It's 30. So we know that it reaches the initial height at a distance of 50 feet, right? So horizontal distance of 50 feet to get back to the initial height. So it's giving you an indication that it's talking about this point right here. So if you want this 50, you bring it over there. And guess what? Here's your axis of symmetry again. If it's 50 from end to end, then guess what this is going to be split into? 25 and 25. So it takes 25 feet horizontally to get to this point right here. It's a little cramped. Apologize for that. But here you've got distance and height. You're at 0:30 to begin. 25, 12, 50, 30. Okay, and away you go. These are some of the scenarios, the most common ones. So don't be thinking, oh, these four take care of everything. As you practice, you'll see sometimes you have to like deal with certain like nuances to help you out. All right, I'm gonna skip 72 because 72 is actually, it can cause some trouble at first because I haven't done a whole lot of that yet. We're gonna do something else instead. I'm gonna go to 73. And we're just gonna focus on the skill of coming up with the points and then coming up with the equation. I just want you to focus on that for now. So 73, 74, 75, and 76, okay? So 73 all the way to 76. Create equation. Once you have done that, right, and you've verified that, you know, I'm on the right track, then you answer the rest. You answer whatever other question I throw at you under that follows. But for now, just focus on creating having your 3 points and then coming up with an equation. That's all I want you to do now. So basically just part A every time. Or B. Sometimes the equation is in B only. So please do that. I'm going to give you a little bit of time to do that. I'm going to look for the answer key. You know what? I will give you the key. I will give you the answer to the first one. And then you'll just go by that. So here we go. Let me just find it. On this first one, you're supposed to get negative 3.686. I rounded it to 3 decimals just in case you round it to 3 decimals, but 2 decimals is fine. Okay, so that's what I'm looking for there. How about I give you the answers to this as well? This will be 5.94 seconds. This one will be 29.54 feet. That's all I'm going to give you for now. Follow me to 74 so I can give you those answers as well. So as you navigate that, you're able to verify where you're at. So come with me to 74. I'm not giving you the points because that is the point of this exercise. The equation though, if you go to B, you're supposed to get negative 0.58 x squared plus 4.96x plus 0.95. I will also give you this one. This is supposed to be 8.69 seconds. And the next one is 4.34 meters. So now you have the answers to those. That's 74. Come with me to 75. Do you need to come up with points here? They're all given. So I'll just give you the equation. This is type 0. Okay, this is type 0. So you're supposed to get 30.65 x squared minus 350x plus 1,000. And I will give you the part B as well. The lowest height of the eagle is 0.82 feet above ground. And 76. So kind of maybe skip 75 for now. I mean, if you want to do it, that's fine. But I want you to focus on the type where you have the story and you need to come up with a third point. This one doesn't even have a table, so I'm expecting you to come up with your table. The equation is supposed to be 0.036x squared minus 0.36x plus 1.2. Sorry about that. I ran out of runway there. This is supposed to be 0.62 meters. What's the QR code doing? I think it's a video that goes through that question. So if you're wanting to watch that one, take a snapshot and then watch it on YouTube if you're stuck. Okay.